Hello, my name is Ilyass Boukhari and welcome in this presentation of drones for wildfires. The problem I focused on are wildfires affecting different regions of the planet every year due to climate change or simply due to human-caused accidents. The problem with wildfires is that they introduce a number of impacts on flora and fauna, as well as harm to firefighters' health and very high cost damage to infrastructures. So, traditional firefighting methods use manned aerial vehicles which are filled with fire extinguishing chemicals and are expensive and present a number of limitations. So, with the research I conducted, I found that drones can be a feasible alternative because of their size, because they can be equipped with sensors and cameras to detect hidden spot fires, and because of their reduced costs. Therefore, my idea is the use of those drones fitted with an internal tank to detect and extinguish fires as well as collect data like temperature and position of fires. Firstly, I produced a Gantt chart which was updated with the project development, and that was to keep track of all the project sections and allocate suitable time for the individual tasks. Then I model a risk analysis which was produced to present and prevent any possible delay or circumstance to impact on the project development, for example, software related issues or the COVID-19 lockdown. Following the aim to present this technology to tackle wildfires, I set some measurable objectives. This included the simulation of some key aspects of the system showing that the presented technology was feasible for the purpose of the project. Firstly, I generated a software energy system on MATLAB, and that was to simulate the battery of the drone and observe electrical data like current, voltage, and state of charge. And that allowed me to understand if the drone was functioning for a suitable amount of time whilst spraying the extinguishing chemical. And secondly, I simulated the software detection of fires with two different methodologies. The first one being with a use of a user-generated heat map to input on MATLAB, and that was to collect informations like value and position of maximum temperature, as well as the distinction of temperature ranges in the image, and that allowed me to ultimately activate the extinguishing system if a threshold temperature was exceeded. The second methodology I used was with an infrared image captured with a FLIR camera, and that was used as an input to detect automatically the fire and again collect major data and ultimately activate the extinguisher after a certain threshold. Another objective was the simulation of the tank flow to know if this was acceptable. So, with a mixture of research and creativity, I used my calculation and created a CAD model, which was finally tested successfully, presenting suitable volumetric flow rates to extinguish typical fires. Finally, I generated a CAD of the drone with internal and external components, and that was to observe the aerodynamic properties by carrying a CFD simulation where aspects like drag, velocities, and areas of pressures have been collected and compared to calculations, showing very low discrepancies. This was to prove that the chosen design was flying fast enough to reach fires before they could extend even more. So, with the initial selection of components, motors, propellers, battery, and so on, costs of this concept were estimated, concluding in a better, cost effective solution compared to traditional firefighting methods. The most interesting part was the creative side of the project, where I transformed calculations, research, and hand sketches into software models of components and the drone itself, where I was then able to observe from the simulation and the behavior of the system on the computer. The most difficult part was retrieving mathematical models suitable for the project. For instance, the tank calculations required a number of variables and unknowns, And in that case, I researched and adapted the Bernoulli equation to the tank model, which in the end found very high similarity with the software simulation. I hope you enjoyed this video. Feel free to contact me if you wish to know more about my research, and thank you very much for listening.